This video covers database authorization. As we'll see, it's a relatively straightforward topic, but it is a very important one. Authorization has to do with first making sure that users only see the data that they're supposed to see, and second, guarding the database from being modified by malicious users. Now, one thing that we're not covering in this video are system or programming security issues, such as SQL injection errors. What we're focusing on is security of the data access itself. So the way database authorization works is that users of a database have specific privileges, and then they can only operate on data for which they're authorized through those privileges. So it's similar to file system, for example, privileges and authorization, except that it's specific to the database constructs, database contents, and tends to be more fine-grained access than we see with file systems. Specifically, for databases, the privileges that are possible are on a particular relation to select the data from that relation, or maybe select just specific attributes, so that's read privileges. As far as write privileges or modifications, we can set up the privilege to insert or non-relation, or even insert specific attributes only of a relation. Most SQL implementations do allow you to insert data with only specific attributes specified. We can have privileges to update a relation or update specific attributes, and finally the privilege to delete from a relation. So let's go straight to some examples. We'll be using the standard college admissions sample database that we've used in other videos. The schema is shown here at the bottom. Let's suppose we have a user who wants to issue the update command shown. They want to find students whose GPA is greater than 3.9, and if those students have applied anywhere, they want to update the application record and set the decision to be yes. So let's look at what privileges would be needed by the user to execute this command. So clearly we're going to have some privileges on the apply relation and some privileges on the student relation. In the apply relation, they're going to need to be able to update the decision attribute, but there's no other update privileges that are needed. In terms of select privileges, or reading the apply relation, the only attribute that's being read here is the student ID, so that's what they need. For the student relation, they're going to need to read the GPA as well as the student ID, so the privilege needed there is the select privilege over the student ID and the GPA. So with this set of privileges, the user would be allowed to execute this operation. In our next example, suppose the user wants to delete all students who haven't applied anywhere. So they're deleting from the student relation where the student ID is not in the set of student IDs in the apply relation. So for this one, again, they'll need privileges on the student relation and on the apply relation. On the student relation, the user would need the delete privilege, and delete never has attributes associated with it because you're always deleting entire tuples. The only attribute that's actually being read from the student relation is the student ID, so the user would also need the select privilege on student ID. And then in the apply relation, again, only the student ID is being read, so the user would need the select privilege on apply of the student ID. And with these privileges, the user will be permitted to execute this operation. So far so good, but now let's introduce a little twist. Let's suppose that we have a user that we want to authorize to access information in the student relation, but only for students who have applied to Stanford. How can we possibly do that? Why don't you give that a thought? Well, I'll give you the answer right away. The way we do that is actually by using views. So we can create a view that gives us the student information for Stanford applicants only, and then we can grant users privileges on the view rather than directly on the relations. So here's our view. It says we'll find all students where their student ID is in the IDs of the students who have applied to Stanford, and we'll call that view SS for Stanford students. Now we can give a particular user the select privilege on SS, and that allows them to select the data that's in the view but not see any of the data outside of the view. Specifically, they won't be able to see student information if the students didn't apply to Stanford. Let's take a look at a second example that involves views. Let's suppose that we want to authorize a user to delete applications, but only applications that are to Berkeley. So again, we'll set up a view. This one's a little simpler. It's just a view of the records in the apply relation where the college name is Berkeley, and we'll call the view BA, and then what we want to grant to the user is the ability to delete the delete privilege from the BA view. Now in this case, we do need to have that view be updatable by the system that's supporting it. So in our videos about views, we discuss this issue. Those are the only examples I'm going to give for now, but I do want to emphasize that views are quite important for customizing authorization to specific user needs. And in fact, authorization is one of the most important uses of views in database systems. Now let's look at how privileges are obtained. When a relation is created, the creator of that relation becomes the owner of the relation, and the owner of the relation has all privileges and furthermore may grant privileges to other users. So there's a grant statement in the SQL standard, and it looks like this. We grant privileges on a particular relation to one or more users, and we have the option of allowing those users to further grant privileges to others. Specifically, the privileges themselves are the ones that we defined earlier, and we can have a comma-separated list of them. So, for example, we could say here something like select student ID, comma, delete, and that would give those two privileges. The users are a list of actual usernames on the database. There's also the predefined user called public, and that would grant the authorization to any user of the database. And finally, the grant option allows the users who are getting the privileges to grant the same or lesser privileges to other users. Now, what do I mean by lesser? Well, it's pretty simple. If we have, say, select and attributes A, B, C, then a lesser privilege would be something like select A and B. Now, how about the revoking of privileges? This gets a little more interesting. So the command is revoke privileges. Again, it will be a list of privileges on a particular relation from users. And again, that would be a list of usernames with the possibility of the special name public. And then there are two options for revoking privileges called cascade and restrict. And they have to do with what happens when privileges are being revoked from a user who was granted the ability to grant privileges to others. So let's take a look pictorially at what can happen. Let's suppose that we have a user who has a privilege to, say, select on a particular relation R, and we'll draw that as the root of a graph. And let's suppose that's, say, user U1, and let's suppose that user grants to user U2 the same privileges, select on R, and let's suppose that's with the grant option. And this is user U2. So user U2 is allowed to further grant privileges to other users, and those may further grant privileges to others, and we may get a big subtree here. Now let's suppose that user U1 decides to revoke the privilege that was granted to user U2. So what Cascade says is that if there's a revocation of that form, then it will cascade down the tree. So if U2 further granted privileges, then those would be revoked, and so would any privileges down below. So this entire subtree is effectively removed, all of those privileges. However, we have to be a little bit careful because it's possible that, say, U2 was granted the select privilege by a separate user, I guess we'll call this one U3, who also granted exactly the same privilege, and in that case, if U1 does the revoke, we don't want to revoke U2's privilege because U2 got it from another source. So technically what Cascade says is that when we revoke a privilege, we revoke any privileges transitively when they weren't also granted by another source. So what you're seeing here is actually called a grant diagram, and I'm not giving you all the details of grant diagrams, but you can see basically what they're due, and they're used to properly cascade the revoking of privileges. So again, the cascade option in the revoke command says to also revoke any privileges that were granted from the ones being revoked transitively unless they were also granted from another source. What the restrict option says is that the revoke command is not allowed to execute if Cascade would revoke any other privileges, so if we have any of those transitive cases. So if we do have the transitive cases and we want to use restrict, then we have to manually revoke those privileges, effectively bottom up through that graph that we saw. Incidentally, restrict is the default in the revoke command, so if neither of these options are specified, then restrict is the one that will be enforced. Lastly, let me talk a little bit about where privileges actually reside in reality. So we have our data that's being managed by a database system, and typically we'll have application developers who are working directly with the database system, often developing modules that will be invoked by the end users. So those application developers have to have privileges on the database to create the modules. But then we have the software that sits above the database system that is used by end users, and the end users typically don't have privileges themselves. They might have separate separate privileges to access the modules, but they're not going to be using the privilege system of the database system. And similarly, there may be even more software layered on top of the software that the application developer builds. And again, that software itself wouldn't be having database privileges, but might have an authorization system for the software that it's accessing. To summarize, database authorization is important. It makes sure that users only see the data that they're authorized to see. It guards the database against being modified by malicious users. There's a privilege system similar to file system privileges but specific to database constructs, and users can only operate on the data for which they're authorized via their privileges. There's a grant statement and a revoke statement in the SQL standard for granting privileges and revoking privileges. And again, when a relation is created, the owner of the relation starts with all privileges. So that's where the granting would begin. And finally, for having privileges that go beyond simple table-level operations, views are a very important construct. And in fact, authorization is one of the most important uses of database views.